Okay, in this video I'm going to go over, quickly go over the 4-inch power chamber horns that I also show in the book. I'll go over one other diaphragm idea. That's making your diaphragms out of this roofing flashing aluminum. And then we'll move right on into showing you, now that you've got your horn put together, I'll show you how to start making sound out of that. So let's go back to the 4-inch power chamber. The build for the 4-inch power chamber is identical to the 3-inch power chamber. The only difference is everything's just a little bit bigger. We're going to have the 4-inch down to 2-inch reducer for the power chamber. Then you're going to need a 2-inch down to 1-inch diameter reducer bushing. That's going to be glued in the front. That'll allow you to have a 1-inch pipe. There's our 1-inch piece of pipe. This one's cut quite short. I've got another 2-inch by 1-inch reducer bushing for the back. Of course, that's going to go in the back side all the way in. I don't have this one drilled out, or ground out, so I'll just take that out. And that goes all the way up on the inside like that. You're going to be making your front ring, the spacer ring that goes up in the front. You'll be making that out of 4-inch PVC pipe, and your 1-inch tightening ring that'll go on the back, same thing. Make that out of your 4-inch pipe. You'll be making 2 of the cushion rings, the gaskets, out of the craft foam. And you can either use one single plexiglass polycarbonate diaphragm or 2, depending on what you like. 2 is a little bit stiffer. I just put them back to back together like that. It helps stiffen it up, makes it maybe just a little bit slightly louder than just using one. But everything about the build itself, same thing. You put the barbed nipple, same area on that one, right up here in the tapered area. It'll be just like the 3-inch power chamber. A lot of people ask me which I prefer. Personally, I think the 3-inch is about the best. The 4-inch, I think it was wishful thinking at first. I thought maybe they were a little bit louder than the 3-inch. At this point, I really don't think there's a whole lot of difference in how loud they are. The 3-inch is just cheaper to build. The parts are cheaper, of course, smaller. Yeah, everything about them is cheaper, and the amount of air that they use is less, because you can see the volume difference between the 3-inch and the 4-inch. It takes just that much more volume of air to get these to start blowing, because you have to fill this whole chamber with the 3-inch, of course, smaller chamber to fill up with air. So they're a little more economical with air to use the 3-inch also. So personally, 3-inch is my favorite. They're more compact, depending on where you want to fit them. If you're trying to put them on a vehicle somewhere in a tight area, these obviously are going to be a whole lot easier to fit. I'll go on to show you the other diaphragm. The polycarbonate is my favorite, but some guys like to go with the aluminum diaphragms. This is what we call, here in Michigan at least, roofing flashing. You can buy it at any hardware store. This would sit on the drip edge of your house underneath the shingles. It comes in a roll. When you get it, it'll be all rolled up like that, real tight. It's super springy material, really springy aluminum. And it's 0.008 inches thick. So it's very thin, 0.008 inches, 8/1000ths. You'll want 2 of these per horn, and I usually put the foam cushion ring on the front spacer ring. Then I put a diaphragm. Then I'll put another cushion ring on top of that diaphragm, this diaphragm behind it, and then take another foam gasket and put it on the back side. And then you'll put your tensioning ring, tightening ring on the back side of that, of course. So it'll be a little sandwich of aluminum, foam, aluminum, and then foam on the back. And using 2 of them like this helps make it stiffer. And you want the foam cushion rings because that's going to seal the air. If air happens to get in between the 2 diaphragms, it'll buckle the back one out and it'll blow it out basically. The nice thing about the aluminum is, with the polycarbonate, that holds back so much pressure that you can't blow that with your mouth. Once you get them set up right, there's no way to blow the air through it with your mouth. The aluminum diaphragms are flexible enough, you can actually take hard mouth pressure and blow these horns with the aluminum. And I'll show you quickly here. This is the very first set I ever built of the PVC pipe horns, and I didn't know, obviously I've refined the design a lot since these, but I just started buying all kinds of PVC parts and putting things together. But these have the aluminum diaphragms in them. That's what I started out with. And I'll show you, these can be blown with your mouth pressure. Takes a lot of air, but you can do it, and it actually sounds pretty good. So if you're interested in doing it with just mouth pressure, then you have to go with the aluminum diaphragms. So that's that part of it. Now we'll move on to actually making sound out of your horns. You've got everything glued together, you've got your reducer bushings all glued in, you've already got your brass nipple threaded in nice. We've got our pipe with our rear reducer already put in there. We've got our foam gasket and our polycarbonate and another foam gasket behind that. And then we've got our tightening ring on the back side of that. When you look in the back side of that, you should see, just like I have mine here, that rear reducer should be perfectly centered in the middle of that. If it's off to one side or the other a little bit, even just a little, nothing is going to be straight and flat in the back, and that rear reducer won't lay flat on the diaphragm, or the diaphragm won't lay flat on the reducer, and it'll leak air in one side or the other. We want that just perfectly flat. If that's centered, it'll lay perfectly flat on there, and that'll seal up really nice and tight when we put some preload pressure on it. What I mean by preload pressure is, that isn't, I'll pull it back away from here. Right now, this isn't touching, the rear reducer isn't touching the diaphragms. I got it pulled out away from there. So what I'm going to do, okay, I can blow air freely through there. What it's doing, it's coming in the barb nipple, in through the back side, around between the diaphragm and the rear reducer, and then going out the pipe. Right now I don't have any pressure against there, it's just blowing straight out the pipe. So I want to tap this pipe back a little bit. Okay, I've tapped it a little. Still no back pressure, no preload pressure as I would call it. Okay, you just heard the tone go up as it just touched the diaphragms. Okay, there's just a little bit of resistance there. It's not quite pressing hard against them yet, so I'll tap it. At this point, I know it's touching the diaphragm. I would take a pencil usually, and I'd mark a pencil mark on the outside of the pipe. That way when I tap it back, I can kind of watch the pencil line disappear. That's about all I want to go at one, each time I do it back, because just one pencil line width will make a difference whether it blows good or not. So I'll tap it back just a little bit more right now. Okay, I heard a little higher pitch that time. Okay, it's getting closer. It's taking more pressure to stop the air. I should get to a point, just to the point, where I can't blow air through this with my mouth pressure anymore. If I get just to that point, then it should be good preload pressure. Still a little bit. Okay, right now, as hard as I can blow, I still can't get air to go past that diaphragm. So that means we have this rear reducer pressing hard enough to where, it's going to take at least probably 20 psi to get that started. So I've got my little blow gun here. I'm going to hook it on. Well, first I'm going to put my funnel on it, so I get a sort of a true sound out of it. Otherwise, if you do it with just a pipe on it, it'll give a high squealing noise. It won't really sound much like a horn. So we'll put the funnel on there. I got the funnel cut, of course, to fit just nice and snug over top of that pipe. And got my full length yet. Let's see if we can get sound out of it. Put my gun on there. So that's giving a pretty good tone already. You might have to play with it just a little bit, either pull it back out just, you know, pencil line width, or even maybe tap it back. Chances are, if you can't blow through it with mouth pressure, that you've already got plenty of preload on it, and possibly just a little bit too much. So like I said, you might have to play with it just a little bit to get the perfect sound out of it. And you can experiment back and forth to see if you get better sound by moving it just a little bit. Once you got it set right where you think you want it, and you want to leave it there, the thing I do here, because this pipe, with the amount of vibration that you get on this pipe, for some reason they will actually tend to suck back inside the power chamber. Even with the pressure in there, I don't know how it does it, but they will tend to suck back in. So you might get a quick squawk or a blow out of your horn, and then it'll lock right up on you, and it won't make any noise at all, and you can't make any air go through it either. What's happening is the diaphragm and the rear reducer are just suctioning right together, because this pipe is actually moved back a little bit. What I do there to prevent that from happening, I used to always say just take a little PVC glue and put around there to hold it. Take a toothpick and some PVC glue around there, but that really a lot of times will break right loose anyway. So what I started doing is just taking a small machine screw. See if I can get a good close-up of that so you can see it a lot better. But a small machine screw. I take a small drill bit that's just slightly smaller than the threads on the screw, and I drill all the way through the hexagon part of this reducer bushing, go all the way through, and then through one side of this pipe. And you can't see it on the inside of the pipe there, because I drill through one side of the pipe, and then I just take the screw, I thread it in there, and I thread it just till it just reaches the inner edge of the pipe. And I don't want it to protrude, well, I'll show you this one. I don't want it to protrude inside the pipe diameter, you know, the inside bore. I want it to just come through the edge on the inner wall and stop there. Otherwise you might disrupt the sound waves coming out. But using a set screw like this really works nice. It really keeps it from sliding, keeps your pipe from sliding back and forth. And then you shouldn't have any problems with it after that. We got it sounding good right now. So this one here that I was just working on, you've got this sounding good right now. So now you're going to get down to the point of tuning the horn, and that's probably for a lot of the guys, it can be a lot more frustrating than the rest of the build, trying to get the right note that you're looking for. And inside the book you'll see a list of all the train horns that are in use, the Nathan Air chimes, the Leslies, all the different varieties of horns that are out there. The list also includes the notes that they play, and it'll include the hertz level that they play. So you can tune it by note and by hertz level. The link that I give you with the videos, 7th string, www.7thstring.com. That's the site that has the tuning section on it that I send you. And you can use that with a computer, a laptop computer, or a desktop computer if you had a microphone set up so you can pick up the sound waves of the horn. And I use my laptop computer. I think most laptops nowadays have a built-in microphone. So if you get on that site and you go, there's a little sidebar on the left that'll say tuner. I think it just says tuner on it. And you click on tuner, and it'll bring up the screen with showing what sound your horn is putting out when you're blowing it. And it'll show the note and it'll also show the hertz level. And in the next video, I'll be actually showing you the screen and showing you what it does. I'm just kind of right now giving you a little idea of how you're going to go about tuning. So right now, you would end up, I tell you, a 12-inch pipe. So you're going to have a long pipe already, full-length funnel like this. And you're going to end up with way too low of a note with 12 inches of pipe on here for a train horn, if you're looking for the train horn sound. If you're looking for a ship horn sound with a lot deeper sound, say in 150 hertz range or 130 hertz range, something like that, that's a lot lower note, then the 12 or even 15 inches of pipe would be good. But for train horns, you're going to be cutting back shorter. But I just start you out long to give you extra length of pipe to work with. So what you're going to be doing is, you're going to leave your funnel length long to start. I usually start with the lowest note first, start tuning for the lowest note, and then if for some reason you cut the pipe back just a little too far and you end up a little higher note than you really wanted for that, then you can just go to the next horn and say, okay, I'm going to tune to the next higher note and use, you don't have to scrap your pipe. You can say, okay, I'll just tune it back a little farther and hit the next higher note. So what you're going to do is, at this point, you're just cutting this pipe back a little bit at a time, maybe an inch, and when you get really close, start going to a ½ inch at a time, cutting off the pipe. And you're going to have to take your funnel, put it back on each time, and you can adjust the tone a little bit just by moving the funnel in or out. And you'll notice that quite a bit when you're blowing it. Try it with it way out on the tip a little bit, blow it, and then pull it back about an inch or two and try it, and you'll really hear the pitch change. But for the most part, you want the funnel within maybe about 3/4 to an inch towards the end. You don't want to come way back, because if you come way back, the pipe is going to be sticking out into the opening of the funnel, and your sound waves won't. What they really need to do, your sound waves need to cling to the wall. Okay. So as they come out of the end of this pipe, they need to be sticking to the wall and following the wall of the pipe all the way, or the funnel all the way out, and then blasting out the end. If you stick this pipe way out in the middle here like that, it's not going to be loud at all. It's going to sound really pretty bad. So you want it just on there 3/4 of an inch to maybe an inch. So at some point you're going to hit a note, you're going to try to hit the higher notes, and you're going to have this cut back to about 3/4 of an inch long to maybe an inch long, and that's about as short as you're going to be able to get it and still keep your funnel on there. And at that point, I take a 3/4 inch coupling piece and I slide it over top of that, and that helps open up the throat of the funnel. So you're going to have a coupling piece around the tip that you got there, and then you're going to have to cut your funnel off a little bit higher up, of course, shorten it somewhat so that it'll slide over top of that coupling piece. And what that does is it opens up the throat of this funnel faster. Your pipe is wider at that point with the coupling on it, and that raises the pitch. If that still isn't high enough, then the next thing you're going to do is you're going to do something like on this one that I have here. This particular set is tuned to the P3 or the M3, either one. They both blow the same notes, which are C sharp, E, and A. So this one's tuned to A, which is 440 hertz. And this is, I have the coupling piece on there. Now that I actually painted them, I don't know if I can get that off there. Okay, there we go. I have my coupling piece on the outside of my 3/4 inch pipe, like that. And then I had to cut my funnel end, of course, bigger, so it would fit over top of that. And that still wasn't high enough note, obviously. So then I took my funnel here and started chopping it back. So it's about that long. and the shorter back you get, same with the pipe, the shorter you make this funnel, the higher note that your horns are going to play. And about the highest note you can reach is about C sharp. I've actually added another coupling piece over top of that before to make it even wider, so you're cutting it up there. But yeah, at a certain point you're going to be about that long of a funnel, and you're going to, C sharp is about the highest note you can reach with these. It's pretty tough to get any higher. A lot of the guys want to build the K3 LAs, and D sharp is the highest note for that, and it's almost impossible with these. I tell everybody if they want to build a K5, do a K5 LLA, and the highest note on those I believe is C or C sharp, one or the other, I can't remember which. I'm pretty sure it's C though. But that one is, you know, you can hit that note with those. So, sorry. I think that's all I'm going to cover in this section right here. In the next video, I'm going to have my computer out here, and I'm actually going to set them up and show you how to use the online tuner and how to go about, you know, the final tuning phase of the horns. Obviously they're all going to be tuned for the train horn sound. You're going to want at least 3 horns put together. I've got these 3 here, all tuned to different length pipes. These 2 have full length funnels, but they have 2 different size length pipes. And this one is as short as it can go. The throat has been widened out and the funnel's been cut super short. So you get your 3 different notes that way, C sharp, E, and A. So that's about all I'm going to cover on this one. So look for the next video, and then we'll start going over the tuning, the actual tuning process.